Completing the square is an alternative method to solving for quadratic. So you were able to factor, you learned how to factor a quadratic equation in three different ways. You had the GCF, the difference of perfect squares, and the product of two binomials. So like I said, this is an alternative method that is required for the Common Core math. So you're going to have a quadratic, and you know that it's a quadratic because you're going to see the term x squared. And you will more than likely be asked to solve it using this process, specifically completing the square in order to yield full points, or they're going to give you certain parts of the process, and you're going to have to answer questions that would be appropriate relating to those parts. So in completing the square, the first step is to um, take the value of the constant, which would be this negative 11, and move it to the other side. So you're going to move it to the other side of the equal sign by reversing the operation. Leave the spot open. Do not put anything underneath where you use the inverses, but have it equal to the sum of the numbers that are on the other side of the equal sign, which is 11. The second step is to take the coefficient of the second term, so that would be the 6, and take 1/2 of it. And then you square it. So 6 divided by 2 square is going to give me 3 square, which is equal to 9. You're going to take that value for 9 and add it to both sides of the equations. As a result, you end up with a perfect square trinomial. So we're going to rewrite this quadratic in terms of factors x plus 3 square. They have the same factors. And that's equal to the sum of 11 and 19, so that makes 20. Now we're going to reverse the process of squaring a number, thus solving this equation. So we end up with x plus 3 is equal to plus or minus the square root of 20. You're going to get x by itself by subtracting the 3, from both sides. And then you look to simplify if you can. So we can simplify the square root of 20. That's perfect square times a prime number. So we have 4 times 5, in which case we get 2 radical 5. Bring down the negative 3 plus or minus, and this is your result. As you can see, these two results here, negative 3 plus 2 radical 5 and negative 3 minus 2 radical 5 are indeed two results. It's an irrational number. You would not be able to get these values for x by factoring. You have to use completing the square, or you could use quadratic formula, which is another process that you will learn after this one. Okay, so here's another quadratic. Half the battle was already done. So we have the constant on the right side of the equation, so I'm just going to spread it out a little bit better. I want to leave a spot here for when we take 1/2 of the coefficient of the middle term. So if I take a negative 2, I take 1/2 of it and square it, I end up with a negative 1 square, which is equal to a positive 1. So I'm going to add 1 to both sides. And then I get my perfect square trinomial, but since we've got a minus and a plus, both factors have to be a minus. So it's going to be x minus 1 square, and that's equal to the sum of 4 and 1, which is 5. I'm going to take the square root of both sides. Plus and minus, plus and minus. So we get x minus 1 is equal to plus or minus the square root of 5. Okay, move the negative 1 to both sides by adding it. So we get x is equal to 1 plus or minus a radical 5. Got another irrational result, and that's the answer. So the next one is a little bit more difficult, and the reason as to why is because we have this number out in front of the squared term. If you look at the ones prior to that, we only had a 1 as a coefficient of the squared term. There's an extra step involved as a result. We want to get it to a 1, so the way in which we do that is we're going to divide each of the terms going across on the left and right side of the equation and divide by that coefficient. So it cancels out here and it simplifies in other areas. So we end up with this 1x squared, negative 12 divided by 3 is going to give me, I don't know what happened here. So this is supposed to be 3x squared. So we divide it out and we get x squared minus 4x minus 7 is equal to, it stays at 0. So first step, divide out the coefficient of the squared term, and then follow the rest of the procedure. So we're going to have to move the 7 to both sides, and we get x squared minus 4x, leave a spot, is equal to a positive 7. Then we're going to take 1/2 of 4 or negative 4 that is, and square it, we get a negative 2 square, which is a positive 4. We're going to take that value and add that to both sides of the equation. So we get x squared minus 4x plus 4 is equal to 13. No, I'm sorry, it's equal to 11. And then we are going to write this as a single factor. It's a perfect square trinomial. So you're going to take the square root of 4 here, which is 2. You have the minus and the plus, so it's x minus 2 squared is equal to 11. Square root both sides. And then we solve for x. We get just the radicand x minus 2 is equal to plus or minus radical 11. Add the 2 to both sides, and we get ultimately x is equal to 2 plus or minus radical 11. Another irrational answer. It's a decimal equivalent, and those are values of where this parabolic curve would hit the x-axis. So it wouldn't be on a whole number, it would be as a decimal in between. Okay, so the coefficient of the squared term is not positive. It's not a positive 1, so we want to get it to be a positive 1. So we're going to divide out by the coefficient. Okay, so if I divide everything by a negative 1, I end up with changed signs. So x squared plus, nope, minus 6x minus 7 is in fact equal to 0. Add 7 to both sides. Divide out by the middle term by 2. And then square that, so we get negative 3 squared, which is positive 9. So add positive 9 to both sides. We get our perfect square trinomial, so it's x minus 3 squared is equal to a sum of 16. Square root both sides. And then solve for x. Look to simplify if you can. Okay, so the square root of 16 is going to be plus or minus 4, but let's just leave it as plus or minus 16 for right now. Let's add the 3 to both sides. Okay, x is equal to 3 plus or minus the square root of 16, which is 3 plus or minus 4, and we can get two very nice results for x. So 3 plus 4 is equal to 7, and 3 minus 4 is equal to 1. So as a result, x is equal to a negative 1 and positive 7. Those would be your results. So this is the first time we did not get an irrational number. We got an integer, and they're very nice values that we can get. Okay, so that's the end of the presentation. You'll have practice on this, and when you're done with the practice, you'll hand that in for a grade.